Hello everyone. Electron configuration writing. Noble gas shortcut. So what is the meaning of noble gas notation? Noble gas notation is if we have the long version of the configuration, so how we can shorten to minimize the length of the configuration. So that is we called noble gas notation. So let's go and find out how we can write the noble gas shortcut. You can say this is the periodic table. So this periodic table, you all know the vertical columns we called groups and the horizontal rows called periods. So there are 7 periods in the periodic table. So this is period 1. In period 1 only 2 elements present, hydrogen and the helium. In period 2 lithium, beryllium and then boron, carbon, nitrogen to neon. And this is period 3 sodium to argon. And starting period 4 you can see the middle portion also filled. So middle scandium to zinc, those are D block elements. So from period 1 to 3 we can't see any middle elements. We can see only the first 2 columns and last 6 columns. But starting period 4 we have the middle shorter columns. Now let's see how we can identify or categorize the element blocks. Group 1 and group 2 we call S block elements. So why we call S block? Because when we write the configuration, we can end the electron configuration in S level. For example, group 1 we in S1 type, group 2 NS2 type like 2s2, 3s2, 4s2 and so on. And boron column, this is group 3, 3A, 4A, 5A and then 6A, group 7A, 8A. So group 3A to 8A we called P block elements. Ending configuration is P orbitals. And the middle shorter columns we call D block elements. When we write the configuration, the ending is in 3D orbitals. And the lanthanides and actinides we call F block elements. So S block, first 2 groups, and then last 6 groups we call P blocks, in between D blocks, and these are F block elements. Okay, now let's see how we can write the configuration, the long version. So we should know how to read the periodic table. Let's pick one atom, carbon. How we can write the configuration? Carbon represents 6 electrons. So starting 1s, we need to follow the Aufbau principle, lowest energy to highest energy. First electron filled into 1s level, that is shell number 1, only 1s present, 1s2, only 2 electrons occupied in s orbital. And then we jump into the second shell, shell number 2. Shell number 2 containing 2 types of orbitals, s and 3p orbitals. So each orbital maximum electrons 2. So total in S 2 electrons, total in P subshell 6 electrons. So we can write carbon configuration then 1s2, 2s2, 2p2. And the same way for the silicon we can write 1s2, 2s2, 2p6 up to neon and then 3s2 here, 3s1, 3s2 and this is 3p1, 3p2. Right? Now next step is let's go and find out how we can shorten this long configuration of carbon and silicon or other elements into noble gas shortcut. Let's see how to write the configuration with examples. So first one, sodium. Sodium atomic number is 11. You can see sodium is here in third period first element. So if we write the long version of the configuration, this 1s2, 2s2, 2p6, 3s1. Now, how we can write the noble gas shortcut? So first thing is you need to identify the previous noble gas to the sodium. So sodium is in third row first element. Previous noble gas means in the second period noble gas, that is neon. So without writing 1s2 to 2p6, the first 10 electrons we can write neon and then remaining configuration is 3s1. So you can see the neon, we need to write in within the square brackets neon and then 3s1. Let's take another example, aluminum. So aluminum atomic number is 13. Aluminum is in the third period, it's 13 atomic number. So if we write the configuration 1s2, 2s2, 2p6, 10 electrons, and then 3s2, 3p1 for 13 electrons. And what is the shortcut for aluminum? So aluminum in period 3, the previous noble gas means noble gas in period number 2. The previous noble gas, if you go backwards, and then the noble gas is neon. So 1s2, 2s2, 2p6, first 10 electrons. Without writing, we can write neon in the square brackets like we did here. And then the remaining configuration is 3s2, 3p1. Right. Let's take another example. Selenium. Selenium atomic number is 34. So selenium is in oxygen column. It's located here. Selenium represents 34 electrons. Now how we can write the long version of the configuration? So selenium is 1s2 up to 4p4. Now when we shorten this configuration, we need to identify the previous noble gas to the selenium. So selenium in group period number 4, then we need to find out previous noble gas to selenium means period number 3 noble gas, that is argon. So we can write argon. Argon is 18 electrons. So without writing 1s2 to 3p6, first 18 electrons, we can write argon. And then remaining configuration. Argon 4s2, 3d10, 4p4. That's how we shorten the long configurations, adding previous noble gas to the considered atom. Now let's see how we can read through the periodic table. Let's take the same element, selenium. So we write hydrogen to argon, that is 18 electrons for the selenium, adding argon in the square brackets. Now how we can identify the remaining configuration? So selenium is here, it's the 34th element. Now we need to write potassium to selenium. So this distance we need to cover for the selenium, the remaining configuration. Now you can see potassium, calcium, they are S4S1 and 4S2 because the period number 4. So 4S1, 4S2 and starting here 3D1 to 3D10. So always we write 4S first and then 3D. Then argon, and then let's read the periodic table after argon. 4S2, 3D10, and this is 4P1, 4P2, 4P3, 4P4. Right? That's how we found out next configuration. Sorry. And then let's go to iodine. So iodine, if you want to write the iodine configuration, the previous noble gas is krypton. So krypton represents 36 electrons. So without writing first 36 electron, we can write krypton. So we covered hydrogen to krypton, 36 electrons now. Now we need rubidium to iodine. So this distance. So after krypton, what's the remaining configuration? 5s2 for rubidium and strontium, 5s2, and this is 4d row. So 5s2, 4d10 from yttrium to cadmium, Y to Cd, 5s2, 4d10, and then 5p1, 2, 3, 4, 5, 5p5. That's the remaining configuration of the iodine. So krypton, 5s2, 4d10, 5p5 is the noble gas notation for iodine. So the same way, without writing the long version of the configuration, you can directly write the shortened version of the noble gas shortcut by reading through the periodic table. I hope now you will understand how to write the configuration, how to read the periodic table and noble gas notation.